Hi class, in this video we're going to go over example 7, 8, and 9. So just a couple portions of importance for the distributions. Now remember that the total area under the curve, if it's a distribution, it's going to be 100% of scores. So in example 7, they're talking about a t-distribution. Now your t-distributions are based on the degrees of freedom. So every one of the degrees of freedom, which is based on the sample size, it's going to have a slightly different curve. And degrees of freedom is always going to be one less. So if they're talking about n is equal to 12, the degrees of freedom are going to be 11. Also for your calculator, it uses degrees of freedom. Okay, so in example 7, they want probability. And when we're finding probability values, you need to declare the variable. So as long as you mention z, or in this case t, it's a random variable, that would be sufficient. Now, total area under the curve is equal to 1, or 100% of scores. So for this specific problem, also area and probability represent the same. So if we're talking about the total area or probability that a score is between 0 and 1.27, for the calculator to find it, you have to use the following commands. So go to your calculator and then you're going to use second, and under distribution, the proper command to find area, it's going to be the TCDF. So TCDF will find area, and most of the models use degrees of freedom. So for this specific problem, we want to find the area, or the area under the curve, between 0 and then technically 1.27. So 1.27, it always wants minimum and maximum value from left to right. And then the next command is going to be the degrees of freedom. So we're looking at a size of 32, therefore degrees of freedom, it's going to be 31. So that's the proper command. And we're just looking at 0.39, 32. For some of the Pearson homework assignments, you're going to use about 4 decimal places. Another item that I wanted to point out is that for the distribution, since you technically have to put a bound, if they mention in between or less than, they mean less than or equal. For those two. And then don't forget that degrees of freedom is always equals to n minus 1. Once again, to find the proper command, you're going to go to second, and then technically distributions, you're looking for the TCDF. Now, and in this case, the probability that a t-value for a t-distribution that happens to be between 0 to 1.27 with 32 samples, that's going to be about 0.3932. Typically, the decimal will be sufficient. Don't forget to declare it. Every one of the problems needs to have the variable declared. Now, for your calculator, it'll use min and max. And if it's unbounded, meaning if it goes to the infinities, you're just going to use a very large value. For instance, let me talk about example 8. Now, on example 8, they want the probability that the t-value is less than 1.77. So that means you're including all the values from negative infinity. So there's a little bit of area below this curve all the way to 1.77. And then I'm just rewriting the statement of first declaring the variable, then less than, I'm rewriting it at less than or equal. And then in your calculator, we're going to have to trick it, because the calculator is evaluating formulas. And since this statement says less than, you couldn't really put 0 because for the distribution, 0 is here. And what we're going to do is just put a very large negative value. I'll just put a negative 100. Negative 1,000 may be fine. You're just looking at extreme values. And then the next value, which is the upper bound, is 1.77. And then the actual sample size being 22, that means that your degrees of freedom are going to be 21. And once again, here, we're trying to trick the calculator to evaluate an integral from negative infinity to 1.77, or it's just saying evaluate a formula that goes from negative infinity to 1.77. And any large value will work so that it evaluates the proper formula. At this point, that would be the total area. Remember that total area under the curve is equal to 1 or 100% of scores. And in this case, I'm just rewriting it as equals. Approximately will be perfectly fine to use. 4 decimal places, so I'm rounding it to 0.9544. And once again, here you can put any very large negative value. Okay, so let me talk about the last one. And the last one has the opposite end. It starts from 2.5 all the way to positive infinity. They also view it as a probability. So same as the previous problems, you need to declare it. You can go directly to greater than or equal, but I'm just translating the statement as greater than or equal. And then in this situation, we're going to be activating the TCDF. Now, your TCDF, since it goes all the way to the positive infinity, we want to use 2.5. And then your upper bound, 100 would be perfectly fine. And then don't forget the actual degrees of freedom. So that's going to be 15. And in this case, 0.0123 if we round to 4 decimal places. The last thing I want to mention is that your degrees of freedom, it's what bounds the curve. So that means that a different degree of freedom is going to provide a slightly different curve. And each of these curves, or in this case values, are going to help us estimate what would be the maximum error that you could have on an approximation. Now, for all these 3 problems, they're just asking for probability. Typically, you just provide a schedule where you're obtaining the values, declare the variable, and then technically that would be the appropriate probability notation. That's pretty much it. If you were to not have the same commands, then make sure you go to tutoring or set up an appointment for office hours. Most of the commands are going to use degrees of freedom.